In previous lessons, we talked about the gravitational potential energy near the surface of the Earth as mgh, where m is the mass of the object, g is the acceleration of gravity on the surface of the Earth, 9.8 meters per second squared, and h is the height of that object with respect to the ground or to a reference height. But what happens if the object is not near the surface of the Earth? What happens if it is you going to the center of the Earth, or if you are traveling beyond the stars? We defined work done by a force to move an object from A to B as the integral of the dot product of the force times the differential of displacement, and the potential energy as the negative work. Because we know the gravitational force between any two objects of masses m and m at a distance r, we can use the gravitational force to calculate the gravitational potential energy that works for any distance r. We need to choose a path to integrate, a path to take the particle from point A to point B, but it really does not matter. It does not depend on the path. Because gravity is a radial force, that is, it points radially to the center of the Earth. In the dot product between f and dr, we can project dr in the parallel and perpendicular directions to f. Only the parallel component is going to survive. The perpendicular component cancels, as the dot product of two perpendicular vectors is 0. We just integrate this. The integral of 1 over r squared is minus 1 over r. Evaluated between A and B, so this is the work done by the force. Then the gravitational potential energy is this is the gravitational potential energy change between point A and point B. So we can write the gravitational potential energy at the distance r as, we choose infinity as the origin of gravitational potential energy, the point where the object has 0 potential energy. 1 divided by infinity is 0. We can represent the potential energy as a function of the distance. The gravitational potential energy is negative. This means that particles can be bound to the gravitational field, just like you and me are trapped by the Earth. But there can be objects that can escape, objects that are unbound if they have positive total energy. In the next lesson, we will study what is the minimum energy, minimum speed to escape from a gravitational field. Meanwhile, may science be with you.